In the last session, what we had discussed was one, why do we need to learn programming? Second thing that we learned was how is Python different? And we basically looked at some code in Python now. And we talked about basics of variables, expressions, and statement. All right. So those who are new to today's session, I'll just give them a quick overview. All right. Great. So the first thing we would like to we discussed was why one should program. The conclusion was that programming is for everybody. It's not only a certain set of people. It's for everybody. Okay. And programming is as a vertical or a domain or an industry. It welcomes everyone. Whether you are a mathematician or you are a doctor or you are an accountant, you are a music director, or you are a movie maker or a singer. Programming is for everyone. Okay. In future, more and more jobs would be required in programming. So that's the core idea behind the session, and I strongly believe that everybody will be benefited by learning at least one programming language. So basically, the way it works is that the computer, whether hardware or software, is something that is helpful for people, and programmers are the ones who can interact with hardware and software, and so that it becomes useful. Okay, so why be programmer? To get some task done. Okay, and to build something, either to get some task done or to build something which other people. So what's a program? What is a code, software, or a program? It's a sequence of stored instructions. And the instructions look like left hand out and up, basically dance instructions. So the idea, sole idea is that the programming is easy and fun, and this is how a typical Python program looks like. Python programs, you can see that it's really neat. It doesn't have too many symbols, and Python wants you to indent the code. Okay, indent the code. Indent means putting either 4 spaces or 8 spaces, but be consistent, or putting tag. Okay, so and this is one instruction, this is another, and this is all right. And here, what we're trying to do is we are trying to find out what word is the most popular in this file. So it will first read the name of the file from you, then it will open the file, and then it will collect the words from the file and count them, okay, in this loop. And then it will basically go over the counts of each word and find out which one is the biggest. And afterwards it will print the biggest word. So don't get bothered if you did not understand what does this code mean to you. Okay, you will get it sooner. And so here the sole idea was to give you a quick insight into how does the code look like. Okay, so you can see that the code in Python is really intuitive and simple. That doesn't mean that you cannot achieve something from Python. You can almost get every kind of thing done using Python. Okay, regarding so here then, after discussing the basics of the programming language, we talked about hardware instructions, hardware architecture. Hardware architecture is basically like this. This is Raspberry Pi, and the core inside of the computer. These are the things. These are the macro level things. This is a CPU. This is main memory. This is input-output devices. Then secondary memory. So here, input-output devices are like keyboard, screen, mouse, and other things, while the secondary memory is like disk, where the data is kept permanently, while the main memory or RAM is something in which data is loaded temporarily, and so that the processor is the one who does everything. Processor takes instructions from the memory and get that instruction executed. Instruction could be as simple as move this data from here to there, or read this data from this device and keep it there. So that could be an instruction. The CPU is the one which basically executes the instruction. Okay, so that was about the overview of the hardware. Then we talked about Python. Python is a programming language. It's an interpreted language, and it can also be compiled. Okay. Now, the other question that people can ask is that why do people use? People use it for good software quality because the code is more readable. That means more reusable and maintainable. A good characteristic of any programming is it should be for human consumption. What does it mean by human consumption is that people should be easily able to read it, understand it, and therefore they will be able to reuse it or maintain it. All right. And Python has that one very good characteristic. Second, it should be able to cater to both kinds of needs. It should be able to provide you the constructs or kind of mechanisms for object oriented. If you want to build a game, if you want to build kind of the programs in which you have things which are very much related to a normal world where the inheritance is there, then it's better to use object oriented. Then there is functional programming in which there are when you want in most of the in most of the programming such as the backend server programming, the functional programming style is more useful than the object oriented. All right. So basically the these are the three reasons why people use Python. Then developer productivity because it's dynamic typing, so you don't have to type too much, and hence the overall code size is 1/5 of that of Java or C++. So if you have shorter code, so in summary, the code is very easy to read. The code is smaller in size, and therefore it's more usable, more reusable, more maintainable. If you have a lot of fear of typing, then you will never be able to code, and that's where Python comes in. It does not. It basically makes programming fun because you have less to type. Okay, and and it's less to debug and maintain. Okay, so if you love C++, as ARJ is saying, then you are going to love Python even more. All right, great. So, and the program is portable, as in C program runs on Windows, Linux, and everywhere. Great. All right, Python can work with all kinds of environment and libraries, and that's the reason why most of the people use Python. Okay. Yes, it's a general purpose programming language. It's a scripting language, you can say. And the downside, there is a slight downside that it's slower than C++, but that speed is, that speed hardly comes into a normal programmer's way. Okay, so the way it is that in the cases where a certain piece of code really needs optimization, people write it in C++, and then use it from Python. Your main application remains in Python. Okay, so who is using Python? Python is used by almost every leader, and there are many success stories. And for that matter, at CloudX Lab, the entire backend is designed in Python. Okay, so why? Because we needed a sophisticated way of automating things on the lab, and that's why we use Python. Okay, you can do a lot of things with Python. almost everything can be done. And why not R? That's another question that I very frequently face. Why not R for machine learning? Because Python is basically a general purpose language. So if you learn Python, even if you are not getting into machine learning, you're going to this session is going to be useful to you. Secondly, like any programming, machine learning is also getting into all kind of domains. Therefore, the machine learning would be used in all kinds of environment, and therefore, a general purpose language like Python could be used pretty well. Okay, so these were the reasons behind Python. Python is open source, and here is something that we talked about, that we need to install Jupyter, or you can use the Jupyter located on CloudX Lab. Let me launch Jupyter. So if you log in into CloudX Lab, you go into My Lab, you will see a link to launch Jupyter. Okay, here is Jupyter. So otherwise, you can install at your local machine, and there, okay, and there launch Jupyter from there. So if you go into lab and you click on Python 3, all right. Okay, so you can go to My Lab and then click on Jupyter and it should work. Those who are on E, as in those who are in CloudX Lab at E, they can use F. Okay, looks like the Jupyter on E doesn't seem to be working, so somebody is looking into it because we have just upgraded all the machines. Great. Now, once you are logged into Jupyter, what you have to do is you have to click on New and click on Python 3. And once you do that, you get this is called Jupyter. Jupyter is a good interface to do the interactive computing so that you can keep, like, for example, we defined X earlier 1, now we can define it, and you can add to it, you can say X equals X plus 4. Okay, so you can see that the value is, okay. So yes, we are going to go with Python 3 instead of Python 2 because there are some important enhancements in Python 3 over Python 2. So it's very important to go with the newer language. All right. So basically, if you have CloudX Lab account, you can start using it right away. Otherwise, you can also launch Anaconda Python console at CloudX Lab as well. Okay, let me just log into console as well in case I need. I'm going to show you. Okay, so you're going to go into Web Console. Okay, Web Console is nothing but a way of interacting with the Linux system directly, and you can get anything done from the console. Okay, so here is the console. Here, this is basically the prompt, Linux prompt, from where you can run any kind of command. Okay, any kind of Unix command, and that command will run. Whether you want to work with, say, Python 2, so this is Python 2. If you want to work with Python 3, what you need to do is you need to activate Python 3.6 environment. You have to say source activate Python 3. Okay, now you can comfortably use Python, or if you say Python 3, then launch. Okay, so you can define the variables and same thing. What you see in Jupyter is the same interactive console here, just that this one is here. Copy pasting is a little too hard, but here the copy pasting or moving to the backwards is easy. Okay, say for example, we want to run this one again, right? So we can easily run it. The way you run anything in Jupyter is by saying shift and enter. Okay, shift and enter. All right, wonderful, wonderful. So this is the Jupyter. This is the Python interactive console, and from console you can actually interact with anything. The other services, for example, some of you might be interested in R. You could start R from here. Some of you might be interested in Scala. You can start Scala here. And some of you might be interested in going with, say, Hadoop and Spark and other things. So those things can also be done using, using the console. Okay, so the console provides you the gateway to the entire machine learning and Hadoop ecosystem. Okay, so that was a quick overview of Hadoop. This was a quick overview of, and in case you're planning to use your own machine and you do not have the sign up with Cloud Lab, so what you can do is you can install it on your local machine. Okay, the instructions are given on our blog, and I'm going to give you that link so that those who did not go through it can go through it. Okay, so yes, this is the blog post. All right, great. So, all right. So if you want to install Anaconda on your Windows, the only way it's on installing on Windows is also easier. You can just download and install Anaconda, and it gives you the whole Jupyter. Okay. Very quickly, this is how a big program looks like. Then these are the reserved keywords. We're not allowed to use them as a variable name. Okay, so the basic construct of any Python program is the sentences, and sentences look like this. X equals to 2x. This is, each one is a sentence or expression. We call them sentence or expression. And then programming paragraphs are a little bigger ones. Say, let's say a couple of sentences together, that's a paragraph. And the whole program is also story, is also called a story. Okay, so a very quick overview that these are the sequential steps, like one after the another. So this one will execute after this first one and so on. Okay, so first important thing to know about a program is that there is an expression, and then you can put these expressions one in each line, and they will be executed in the sequence. Okay. And yes, those were wondering that can there be a programming language in which this order is not followed? Yes, there is a programming language. There are newer languages in which there is a lazy evaluation and things don't happen in the strict order. Okay, things happen there based on what's needed. Okay, but in Python, the program is executed from top to the bottom. Okay, these are the conditional steps. Conditional steps means do this only if this is true. Okay, that's if-else statement. And then there are repeated steps in the program in which the steps will be repeated. Here, these steps will be repeated till the point this condition is true. So repeated steps are done via for loop, while loop, and so on. We'll go into more details during the session. Okay. All right. So this is how the program looks like, and let's move on. All right. So afterwards, we talked about variables, and we first of all define what's a constant. Okay. Great. So let's get to the flow where we were till last point. Talked about what's a constant. Constant could be an integer, could be a decimal number, or it could be a string. String is nothing but a text, a line of text, or multiple line of text. Okay. So basically The numbers are just written like this, while strings are written either inside single quote or double quote. Okay, inside single quote or double quote. Okay, and what's a variable? We keep on hearing this word variable again and again. Variable means a location in the memory, which can change. When we say x equals 12.2, it doesn't mean we are comparing x. We are saying there is some place in the memory called x. Okay, there's some place in the memory called x. Set that memory to 12.2. Okay, that's what we are doing here. And let's create another place called y and put 14 in that place. Okay, so if we again assign something to x, then value or older value of x will be overwritten. Okay, so the name, it's important thing to know that names in like we have names. I have named Sandeep Giri, but that kind of name we can't define for our variables. Okay, we should not have spaces in the name. Second, that's a common. I think it's common across all programming language. Second, the name should either start with the name can contain underscores, numbers, and characters. Characters, capital and lower, are considered different. They are not same. Okay, and the name can start with underscore or a letter, but not with a number. Okay, so 23 span or hash sign var.112 is a bad variable name. It's not allowed. Okay, so the other thing that's not allowed is the reserve word. So you cannot keep the variable name in either of these. Okay, reserve words are used for programming construct like a loop or error handling or print statements or various other. These are special verbs. Okay, we should not be keeping. We should not say and equals to. Okay, that's not allowed. Or raise equals to 2. We can't do that. Great. So, all right. So those who are coming from those who have already gone through Python 2, please keep in mind that the biggest difference in the two languages is with respect to this, as in earlier print space x was allowed, brackets were not needed, but now it's required. Okay. Second difference is when you divide two integers. Earlier it used to give wrong results, as in it used to do integer division. Now it does the decimal. We'll talk about it as we go. Okay. Those who are right now trying to figure out the difference between the two, I'll just clear it for you. Okay. These were the two main differences. The third ones are the other ones are very small and insignificant for you. Okay. And rest you'll figure out. Okay, so basically after that we talked about the assignment statement. So the value on the right hand side is calculated and assigned to the variable on the left hand side. Okay, on the left hand side we must have a variable or list of variables. Okay, so for example, do not get intimidated by this thing. It's pretty simple. Let's say the value of x was 0.6. So what will be the result of it? This will be calculated, then multiplied with this, and then multiplied with this. So the value will become 0.936 after this statement is executed. Okay. Now, these are the various numeric expressions. These are something which we all know. The only thing would be these are the two things that would be new to you. Here, instead of x, we use asterisk to multiply, And this is the power. Power means x asterisk 2 is x square. Okay, meaning multiply same thing by same thing again and again. That's power. Okay, yes. And percentage means remainder and so on. Okay, so the order of evaluation is based on the standard BODMAS rule. Okay, and so BODMAS as in the B for brackets or parentheses and so on, right? So parenthesis is executed first and so on. So the standard rules of expression apply. Okay, so if you take a look at this, right? So first of all, the power will be computed, right? And then the multiplication, and then the rest of the division multiplication. If the division and multiplication have equal precedence, so in that case, the evaluation will be from left to right. Okay. All right. So we have talked about this, and we're going to go ahead. Now, one thing is very important to all of us is when we define a variable, right? When we say x equals to 2, the variable x is stored somewhere, and x has got a data type. Data type is needed and for many things. Okay, data type is needed in order to avoid mistakes, and data type is also needed in order to figure out what to do with a value. Okay, so the type is every variable has a type, and some like when you say type, it displays the data type of a variable. Okay, so it displays the data type of a variable. You cannot concatenate, you cannot add a string and a number. Okay, all right. So let me just go ahead, and I think this all you can figure out. Basically, there are various kinds of types of variables, specifically integer, float, and string. You can say type brackets the variable name, and it will tell you the data type of that variable. All right. So you can convert the type from one to another using this way, and you can also convert things into integer by from integer to integer, from string to integer, and so on. So you can easily convert. So here we are converting a number to this. Okay. So here is a quick exercise to all of us, those who have been here. This will be used later today, and it's pretty simple. What you do is x equals, or we say, all right, salary equals input. What is your salary? Okay, let's just say that. And here I'm going to say 10.5. Okay, so when I print cell, it's a string, correct? It's not a number. It's a very important part to all. Okay, so did you try this? So when I entered something, it is a string. If I say cell +1, it's going to throw an error. It's going to throw an error saying the salary is basically a string and 1 is a number, so we cannot really deal with it. Okay, so what you do in this case is you convert salary, and I call it salary float, or let me just call it salary f, and that is float salary, right? So if you say salary f, it will show you that the value is this, and now we can add numbers to it. Okay. Okay, let me zoom the Jupyter window a bit. Now it should be better. We're going to do one more exercise, and we talked about input. Input takes the input from the user. All right. One more thing that we can write comments in our code. Sometimes we want to communicate something to the reader of the code, but we don't want that to be part of the program, right? So let's say, okay. So let's say here show you, we want to show you the, let's say here, um, I want to write something. I want to say, now you can add the number. Okay. So this is a comment. Comment is for the reader of your code, but not for the computer. Okay. This is a single line comment. All the values after hash are ignored. We can even put the comment here. Okay. We can put the comment here. Great. All right. So we are going to do one exercise now. We talked about string operations. We can concatenate two strings like this. I can show you right away. We can concatenate two strings like this. Oh, sorry. One thing to keep in mind is that these codes are terrible. They get translated into something weird. Okay, say for example, here it was not really a single code. It was some other special code. Okay. Can Python do multi-line commenting? Yes, you can put 3 characters, and here you can, this is multi-line. Any questions? The truth is, Python doesn't really have multi-line comments, but you can emulate it by using triple comments. Okay, like this. This is generally used for documentation, and whenever we are defining a, say, function or something, we can write it. It's not really a comment, by the way. It's basically a multi-line string which is not being assigned to anything and therefore is being ignored. All right. So if I say something here like this and say print x, okay. So you can see that this is kind of ignored. All right. Great. So this is basically a way. This is how we concatenate the strings. Okay. And if you want to print something multiple times, okay. Say I have an assignment that write something 100 times, I can simply say I 100 times. Okay. Also, I could say things. /n here means new line. Okay. Just let's keep this in mind for now. That if you want to put tab, we can say /t. If you want to say new line, we could say /n. Okay. These are special characters. Good. And let me just put it a little lesser. Okay. Also, keep in mind that we can here saying something. Yeah. So single quote, like we can say single quote like this. Okay. Or we could say double quote. Okay. So a string can be represented as double quote or single quote. If you put single double quote inside single quotes like this, if we put double quotes inside single quote, that means that double quote is part of the name or a string. Correct? Some of you might be having a name that has single quote in them. So what you do in those cases is you surround your string with double quotes. Okay? Surround your string with double quotes. Now question is, what if my name or whatever string I'm typing, it has single quote, a quote as well as double quote. So to comment out something, you can always put slash before it. So here the string starts from here till the the another double quote. Is it clear to everybody? Not clear? We want to print double quote as well as single quote in the output, right? So if you put, had it been only one of the single quote to double quote, we could have basically defined it using the other kind of code. But since we need to print single quote and double quote, we would have to put uh, slash. Okay, in very simple words, you can define a string using by enclosing something in double quotes or in single quotes. Okay, if you are defining a string by enclosing it in double quote, then single quote inside that string will be handled easily. But if you have defined something using double quotes and you want to put double quote as the output, then what you have to do is you have to put slash before it. Now, when you put slash before it, then this double quote will be printed as such. Okay. All right. Like, for example, I would like to print this way. Okay. See? So double quotes, the slash is ignored. Now, what if I want to print slash in the output? Then I have to put slash before the slash. Okay. And this slash is for this. Okay. So slash double quote became double quote and slash slash became slash. So slash means the slash basically cancels or neutralizes the meaning of a special character, right? So double quote here is a special character that one kind of ends the string. So you put slash before it. Okay. Do I make sense or did I confuse you? Yes. So basically, slash double quote cancels the special meaning, right? What's the special meaning of double quote? Double quote special meaning right now is that double quote is will signify the end of the string. Okay, but we don't want the string to end. Therefore, we put slash before it. Okay, and you'll find these kind of circumstances often. Okay, you find these circumstances often. Okay, you can ask me questions at this point. You can try all kinds of permutations. Let me show you a very simple example. Let's say Sandeep, right? Or let's say this is a code. Let me say. I want to say this is a double quote. Now, how would I say? Okay, so if I write like this, then it'll give an error. You see, it's an invalid syntax because the string ended here and so on. So this is kind of became the code. Therefore, what we needed was to put slash. Okay, so this is what I wanted to print. Do it make sense to you? Yes. So all kinds of special characters, if you want to keep them inside the string, you can put slashes. Actually, with respect to the string, percentage is not really okay. So I found that a lot of us are basically confused about these. Okay. That's why I wanted to go into more details. Wonderful. All right, is everybody with me on this? Okay, great, great. So Now, the variable name is a general question. So, as we discussed, with respect to the computer or Python interpreter, the variable name should not start with a number, and it should only have either numbers, alphabets, or underscores. Okay, so that's the way a variable name is. But that does not mean that we should keep any random variable name. Okay, we should keep a friendly variable name. For example, if we had this kind of variable name, okay, it is completely okay. This is completely okay. This is completely okay with respect to Python. Okay, this is completely okay with respect to Python. You can see that it's completely okay. But the people who will be reading your code, it will be difficult for them to figure out what's going on here, right? But right, you yourself can't figure out what's going on here, right? If you write it in this way, it's still better, correct? This is still a bit better to have a code like this, correct? So we can, okay, so you can see that this is also giving the same result, but it is a little more sensible to me. Now, let's take a look at the another piece of code. Now here, this makes more sense to you, right? It says hours are these many, and then rate is this, and pay is this, correct? And then you print pay. Okay, out of these three pieces, which makes more sense to you? 43, 44, and 45. 45, right? So this one makes more sense to us because it's more humanly. It relates to that. It is must be, related to computing the payment for somebody who has done some work and at some rate and so on, right? That's how we would generally interpret it, and that's easier to handle, right? So if we had more logic here saying per day means 8 hours, so we divide by 8, and that would make more sense. I see, I see. Let me see if I can. So if the screen is not clear, what you should do is you should check with the YouTube settings. At the bottom of your screen, there is something called quality, and you should change the quality to maybe 720p. Okay, there's a setting, and click on setting, and then click on quality, and then you will see. Okay, great, great. I know that this is a bit slow for the people who have already done programming, but these are something really important for the new beginners. Okay, great. Now, let's do this very simply. Okay, let's write a simple program, all of us. All of us write a program to prompt user for hours and rate per hour to compute gross pay. Okay, and yes, do not start pasting the answer um, for next 2 minutes. Okay, is anybody doing it? So pay is basically hours multiplied by rate. Okay, so this basically whatever you enter here, you have to multiply the two and print on the screen. Okay, done. All right, great. So it looks like the time is up. It's 8:02. Okay, and yes, you can actually share using the live chat window itself. All of you can share your code. Question from Gopi is, does Jupyter have a memory buffer? I tried pressing the up arrow key to retrieve the last script. So actually, yes. So it's a good question. So basically, in that case, you just scroll up and you can go and execute it again. See, that's even better. So that you don't have to keep on going, pressing up arrow key. Okay, let me pick the answer. Let me pick Ambia Murthy's answer first. Okay, let's see if it works. I know the new line is a bit of problem. So here I'll have to do a bit of writing. Okay. All right. So enter hours. Okay, I'm going to say 1.2. Enter rate 2.5. Is it correct? Yes. Okay. Great. Great. And same is the case with Rohit. Looks good. Looks good. Partha, the code looks good. And for others also. Okay. So this is our example of code. This is our example of code for. We could put a little space here. All right. And okay. So this is something that you will find it hard to do on the interactive shell, to go back to the previous statement, edit it with the mouse, and then change it. Yes. So I'm trying to be a little slower in the voice so that those who don't understand my what do you say, accent, it'll be easier for them to pick up. I see. The voice is low. Okay. All right. Does it sound better now? Okay, great. Okay, so let me try speaking a little louder. And that will be good. Great. So we did our first exercise. Okay, looks like only few did. Okay. All right. So this could be your first program, and here is the example of code. Okay. So all of you must try this one. I'm going to share a well-formatted code with you. Okay. Great. So this is where I've pasted it, the same code which is available to you. All of you must try. Programming can only be learned by trying again and again. Okay? Most of the code can be learned by trying. Why? Because compiler quickly checks your result and you know what you want to achieve, and it can quickly give you the results instead of somebody telling you what's right and what's not. Okay? Therefore, programming can only be learned by trying and by doing hands-on with me. Okay? Else you will forget everything. Okay, so if you have doubts here, please feel free to ask. Here, the example is very simple. Here, the input function prints this strings to the user, and whatever user types, it gives into hours. By default, input function gives the string. So hours is a string, meaning It's a kind of text, right? It's text. It's not a number. Similar is the case with rate. We showed user this. User entered something here. User has entered 6.7, and that 6.7 has gone as a string. So if you take a look at rate, it's a string. You see single quotes around it? It's a string. And while pay, if you take a look at pay, pay is a number. Those who are still struggling with Jupyter, press Shift Enter to execute anything. All right. So we need to convert, in order to multiply, we need these to be numbers, right? And therefore, what we did was we converted hours into float. And then we could also say things like hours F equals hours F equals. We could even break down this statement into more simpler ones, and we could say rate F as in float, and okay. So, all right. So most of you would be wondering that I can do it easily in the Excel, Microsoft Excel or Google spreadsheet. Why am I learning to program here? Okay. You will see more complicated, more complex scenarios that you can solve very easily using this way of programming. And whatever you're learning here can back applied in the Google spreadsheet and elsewhere also. Okay, so it's about learning to program. These are the baby steps that we're going through. Okay, a question from Mario is there a way to curse the float input from input prompt? There should be a way. You can take a look at the definition of, you can say, an easier way is you can just search Python input function, you see, and that's a good way to learn. See, this one basically shows you the Python tutorial, okay, and this is the built-in function. This documentation is something. Okay, so and the other thing about programming is we must learn to read the documentation of programming language. Okay, and that makes life really easy. Okay. So looks like input prompt does not give you a way of controlling input that way the data type. It will only give you string. You can translate it later. Okay, question from Binda is that could I print out an assignment expression? Could I print out you mean the whole, like a string? Okay, you mean like this? Like this? Okay, so no, okay, because that means something else. A question from Gopi is that my Jupyter has asterisk here instead of a number, right? That means it's processing it. It's doing some calculation and it's basically waiting there. Is there any way we can terminate program in between in Jupyter? You can click on this to terminate. You can interrupt the kernel. All right, wonderful to have a great audience. Everybody is able to do it. Great. Okay, so you can actually terminate the kernel using interrupt kernel, or you can just say restart the kernel and it will restart. Okay. In the back end, when the Jupyter is running, in the back end there is a Python interactive console open that's called okay, interactive console legend. When we type this one, this is exactly what's open in the back end. Question from Gautam is, can I import dataset using Jupyter? Of course you can. You can read any file from Jupyter. Okay, we'll go into those details very soon. Okay, what are the size limitations? Size limitations are something that's imposed by your operating system and the hardware limitations. Okay, good, good. So I think everybody is able to do this, and if not, you must try this. This is the first code. These are baby steps. The only way to learn programming is by doing. Okay, that's what we're going to discuss with that today. Okay. All right, so somebody is suggesting that we could simply say rate into hours and it should work. Okay, so we did not enter correctly. So also what we could do is instead of taking input again and again, we could put it in another cell and execute it. Okay, it says that cannot multiply two strings. You see, cannot multiply two strings. Okay, so whatever we defined here will remain there and we can use it. Okay, so you can download the workbook as a Python program or you can download it as the text. Okay, or you can just copy paste into a notepad and save the results. Yes, so what Gopi is doing, that's correct. Basically, you have to convert that into. Okay, wonderful. So all of you have been able to do it, and that's great. We could basically do this in any way. Okay, you can, this program can be written in many ways, even this one. Okay, so we could actually write the entire thing in a single expression. I'm going to show you how. We could simply say, let me see, what is rate? So let me simply show you. So you could actually write it in many ways. Okay. And, okay. And what's our rate? I can just take this one and put it here and then say this one. This is also a valid program. Okay. Good. All right, let me just do undo a bit. Okay. All right, so so you can structure your logic according to your needs, and that's something good about programming, right? It doesn't have to be exactly same. Great. So all of you are able to write your program. That's great. Now let's move on. Move on to the next session. Okay. Now let's learn something really interesting, and that is conditional execution. Okay. So far, what we learned was very simple, basic mathematical operation that you could do with even a simple calculator. And this is something that if conditions of conditional execution is something that is the heart of a program. Okay. The conditional expression is something that the computer is made of. Okay, conditional expression is something that requires more computation. You will learn this part why. And so, so the computer executes your instructions from top down. That's what we've learned so far, right? Now, if you want to execute something and you don't want to execute something else, you can use conditional steps. So conditional steps that you see here is uh, uh, with if-else conditions. So the program is you define a variable here. Here we're defining x equals 5 and x is greater than x is less than 10, then print smaller. So it will print smaller here. Why? Because x is lesser than 10. If x is greater than 20, it will print bigger. Okay? So here what we could do is we could say very simply, we could say enter rate. Okay? And then we could say if rate, we could say if float of rate, right, greater than 10, you say print you're too costly. Okay? And else print. We will talk about else later. Okay? So if you say 50, it's going to say you're too costly. Right? Okay, so when I'm putting something on chat, it's taking away the new line. All right. So this is if statement. All right. Now here there are multiple parts to it. One, if is followed by a condition. There is no brackets here. There is a condition. Condition could be greater than, equals to, less than. Any expression is a condition. It should return true or false. Okay? True or false. Or it should be some value instead of none. We'll talk about none part later. So what you see is a very simple program. It starts with x equals to 5 for now. If x is greater than less than 10, it goes here. Otherwise, it goes here. Since x is less than 10, so it will go here and print smaller. And then come back to the same point. And then here. So if you see, look at it closely. This program is far more readable than actually the diagram. Which one you find more friendly, the diagram or the program? That's right. The program is far more simpler than the diagram, actually. Okay. Great. Let's move on. Now, when we compare two things, it could be lesser than, equal to, lesser than, equal to, or equals. This is a comparison operator. Unlike the assignment. This is comparison. Okay. So if I say here, if I say x equals 1, that means false. If I say x equals to 1, that is assignment. Okay. Now, if I go back and say, now it will be true because value of x has become 1. Okay. Right? If I say x equals to 3 and then say x equals 1, then it becomes false. Correct? All right. So this is comparison, while here we are putting 3 into x. Okay. We make a lot of mistakes because of this particular construct. Okay. So this means greater than or equal to. This means greater than, and this is not equal to. Okay. This is not equal to. So, okay. So basically, we can do the comparison and we can write a program like this. Okay, so here what we're doing is, okay, and we can actually write a better program. Okay, here we go. Okay, so what we are doing is we are saying x equals, not x equals, I'm saying x equals input, and I'm saying question mark. Here I'm reading from the user. So if I say 5, it's going to say equals 5, greater than 4, greater than equals to 5, greater less than 6, or less than 5, not equal to 6. If again I execute and this time I say 6, it says it's greater than 4 and it's greater than or equals to 5. And again if I execute and say 7, right? So basically if it's greater than 5, what happens is this won't get executed, right? And sorry, this won't get executed, this will get executed, this will get executed, and this will get executed. Okay, makes sense, right? So if we are saying if all of these conditions are going to be checked, all of these conditions are going to be checked, but only the ones where the condition check return true, only that will be executed. Okay, so here there is no explicit statement for if and only if. Okay, there is something called if else that we'll talk about. Great, so this was a very simple if. Okay, that was a very simple if. Sometimes we would like to do more. We would like to do more inside the same if statement. Okay, and I'm just saying if. Okay, so you see, if I enter 5 here, so these two lines are part of the same block. These two lines are part of the same block. Okay, we did not have to put any curly brackets or anything. We just have to put the next statement with the same indentation. Okay, therefore indentation is very important. Indentation is how Python figures out that you're done with these lines. Okay, so if I say like this here, if I say print something, this is going to be executed even if value of x is 4. See, something is printed. Are you scared of this big program? Or you want me to cut it down? Okay, is this clear? So print something got executed here. Something got executed, something got printed, even though this line wasn't. So it detects that the block has ended based on this space. So while this line will get executed, if this condition is true, this one will get executed once this whole block finishes. Great, great. So this took me a while when I came from Java to Python. It took me some time to come back to this. Okay, now, so indentation. So increase indentation after an if statement or for statement. We'll talk about for later. So the block, and in most of the other programming language, the block of code is marked with curly brackets. Here, it's basically the indentation. It enforces the clarity in the code. The formatting is enforced by the programming language, and that's one of the reasons why I like Python, because the code always remains readable. Okay, so maintain indent to indicate the scope of the block. Okay, so we've talked about this. Blank lines are ignored. They do not impact the indentation at all. Okay. Comments on line by themselves are ignored with respect to the indentation. Okay, so if it doesn't matter what kind of indentation you're using in comments, or even if you're leaving the whole line empty, it's ignored. If you're leaving the whole line empty, that's ignored along with the comments. All right. As a general, if you are building a program and you're writing the program in a file, so also those who are wondering how to run this, we have already talked about this in the previous session. So you can actually save the file somewhere and then you can run it either from within the Jupyter using %run, or you could do it from the console. In your text editor, you can what you can do is in the text editor you can set the indentation to spaces. Okay, it's not a good practice to keep the when you are building a product and you're writing code. So what could end up happening is the size of tab on your machine could be different from another person. Therefore, most of the text editors allow you to set the value of tab to 4 spaces. Okay, that would keep the indentation clear and simple and similar for all. Okay, so you can now clearly see that from here to here is you cannot control tabs in case of Jupyter, but in other text editors you can do it. Okay, so here the advantage of the indentation is you can see that it's very clear that from here to here it's part of this condition, meaning this will be executed only if this condition is true. Similarly, this condition, this whole block will be executed for in this format. Okay, great. So it makes it makes the whole thing very clear in case of Python. So the indentation makes life really easy for readers as well as writers of the program. Okay, so you could actually do if statement inside another one. Okay, so you could define nested if else statement, and there is no limit to it. Okay, you could keep defining if else inside one another. Okay, so this is the here you see if x equals 42 and if x is greater than 1, then do all of this. Okay, and if x is less than 100, then do this. Okay, I'm going to show you this part as well. It's going to be all right. So you can see that the indentation is double indentation is required for the nested conditions. Okay, so you see that this will be executed if okay, and if let's say this was 420, so then what happened was if x is greater than 1, this got executed, but this did not. Okay, so this was a quick overview of the nested. Now there could be an if-else statement, the two-way, as in if this condition is true, go to the right, else go to the left. We'll talk about two-way decisions after the break. Okay, so let's take a break for 10 minutes. All right, so should we start? Can you hear me? Hi everyone, I'm back. So should we start? Wonderful. Wonderful to have all of you back. And sorry for the mic being on. The mic was left on. Okay. And all right. So is everybody on the same page? Are you able to write the if else conditions? We're going to have a couple of exercises as we go ahead. Okay. So for now, we should be able to write the if else conditions. Okay. Great. Now moving ahead, and let's try to write a simple if else condition. Okay. If else condition as in if this, otherwise this. Okay. If this, otherwise this. Okay, let me show you here. So we are saying x equals 4, and we are saying x equals to, if x is greater than 2, this is a condition, this is an assignment. So we are saying x equals to 4 means the value at x will become 4. You want to see here, I'm saying print x. Okay, so the value of x is 4, and we are saying if x is greater than 2, print bigger, else print smaller. Okay, and then you print all done. Yes, great. And all right, let's okay, so you can build a very complex condition, or you can build very complex conditions using these if else statements. Okay, you can build many complex scenarios with this. So you could also say things like if x is greater than 2 and is something I'm introducing now. Okay, 6. Okay, and here you could also say elif. Okay. If x is less than 2, sorry, I'll do something better. Let's say if x is greater than 400, and I print hues, right? And then right. So we could write else if statement as well. So we could write if or if else like this, or if we could even write else. Okay, good. Is everybody clear about if, elif, and else? Elif is else if. Elif is else if. So if this condition is true, then this will get executed. Otherwise, if this condition is true, then this will happen. Otherwise, this will happen, and this will happen all the time. Okay, this will happen for all kinds of values. So this is else if, right? Okay, Okay, let me take a look at Gopi's code. Okay, Gopi's code is this. And we are saying rate equals input. And if condition is this, and we say this. Also, there are these dots which are special characters. It says there is need to be a colon, and it says else here, and you have to put a colon here. Okay. So keep in mind that this is something again. So if followed by a space and a condition, then followed by a colon. Okay. If you want to go with the block, then you can put a tab in the new line and put your next statement. Okay. Yes, yes. The check is basically the right. So it's again, it's asking you to convert it into float, right? So first, before comparison, you have to convert it. Before comparison, you have to, okay, you have to, let me see what happened here. I'm saying float here and let it be this way, okay. I'm just wondering what happened here. Okay, so I'm saying if rate is greater than 15, then how can I start printing rate? Anybody can find problem in this? Okay, let me see what's happening. Do you see anything wrong with it? Oh, I see. I see. So this is happening. This is correct only, right? So we're saying print. Let's say good. Okay, so it's correct only. Yes. So you got the answer, Gopi. The problem with your code is float object was to be converted. So we had to convert the string into float. Because we cannot compare the string with the number, and therefore we had to convert it. Let me try with 5. Okay, great, great. All right, so that was our simple experiment with if else. Okay, so you can create all kinds of complex scenarios, and I don't think Python has a switch case statement because you can do the same thing with if else if kind of conditions. All right, now the next is the try except structure. Okay, whenever whenever we are working on something and we expect some kind of error, we should put try except. Okay, that way we can handle the errors. Okay, the error that Gopi recently faced, for example, where we so those kind of errors should be handleable using the try and except structure. Okay, so let me make it full screen and talk about it a while. All right, so the dangerous sections of your code where you expect certain error and you know how to handle it, in those cases, you put try except kind of condition. This makes your code being able to do the error handling upfront and deal with all kinds of errors by yourself. Of course, Python wouldn't automatically handle the errors for you. You will have to write logic for the same. You will have to write logic for the same. So the way it works is that if the code in try block works, then there is no the things which are in the exception or after except are skipped. If the code in try fails, the logic jumps to the except section. For example, this. Here is a simple Python program. And here, let's say we are asking for the salary of somebody or the number of somebody, and then we are printing that. And the error occurs here, right? Error occurs. For example, in this case, what we were doing just now, we were doing this, right? Doing this, right? And the user entered something like this. It would give an error. It would give an error. Okay. So we can surround this logic with try. We could say try, and we could say except, and we could say except, and we say print please enter a valid number. This is your last chance. Okay. Good. And again, we put the same logic here. Okay. So what we're doing is we are, you see, so what we're doing is we are asking for this, and this is okay. But if we say something else, it'll say, please enter a valid number. This is your last chance. Yes, this is same as try catch of Java. All right. So basically, this is also called as error handling. So we were able to do the error handling easily, right? Although here it will only try once, and if I do it again, it'll give an error. You see. So here again we'll have to put try except. Instead of that, we would generally go for loops. We'll talk about loops later. Okay. So it'll keep on asking for a valid number until you have given a valid number. Okay, so we'll talk about that later. So what you see here is a simple scenario of error handling. So what you do is whatever code or logic you have that you are expecting certain kind of errors in that. Around that, you put try and except. And under the except, you should be able to write your error handling code. Okay, does it make sense to you? Yes? Let me increase the font a bit if that is good. Okay. And hide the header, toggle toolbar. Okay. Great. Is everybody with me on this so far? Did you try this? Did you try to put try catch? If not, try this now. Okay, and try entering invalid input. Okay, all of you must try the things with me. Only then you can learn. You can learn programming. Okay. In the olden days, we used to do the lab after this class because computers were in another room. But now you can do it during the session itself. So it's important that whatever we learn here, you should try it together. Okay. Only then you will retain, otherwise you will not retain even a single thing from the class. Okay? Wonderful. Only 3 people have tried so far. So this is the way you handle errors, and this is going to be very useful syntax at later point of time. Okay. When there is some error with input, or whether when we are dealing with some other file or other logic, we should be able to deal with the errors using try except. Okay, great, great. All right, so I think this model will work better. All right, so the way it works is it asks you for a value, and then whatever number you enter, it will do the read it, and then try to convert that into integer. So let me just write this code for you. Here, what we're trying to do is we are saying a string equals input, right? Input. Basically, this is the thing which we are trying to do. Okay, let me. Okay, so we are saying a string is hello, and under that we have I string equals integer of a str. Okay, and typing mistake. So it says that this is not an integer, right? So what we do in these scenarios is we put it in the try catch. Okay, so in try except, try this, and in case of exception, assume it to be -1. Okay, if this is invalid string, let's put it -1. Similarly, here we have done this. Okay, so basically, try except is a way to deal with errors. All right. Okay. Now, all of you rewrite your pay computation to give the employee 1.5 times the hourly rate for hours worked above 40 hours. Okay. So if somebody has worked for more than 40 hours, for the overtime, give them 1.5 times the hourly rate. So 40 hours is, beyond 40 hours is considered the overtime. Beyond 40 hours is considered overtime, and if overtime is there, you have to give them a hourly rate of 1.5. So your program should read hours from the user, rate from the user, and print the pay. Is everybody clear about the question? So earlier what we did was we computed pay by just multiplying hours into rate, right? We computed pay by multiplying hours with rate. And what we are trying to do is that in case somebody is doing overtime beyond 40 hours, give them 1.5 times the hourly rate, only on above 40, okay? Only on above 40. Let's say somebody entered 45. 45 is above 40, right? So 5 is above 40. So 5 will be multiplied by 1.5 times the rate, which is 15, while remaining 40 hours will be at the rate 10. Is it clear? This is, by the way, this is how your tax is also computed. Income tax is computed this way. The salary slabs and all. That's a little more complicated. So we'll go with a very simple one first. Are you done? So write a program which asks for hours, which asks for rate, and which prints the pay. So you want me to write it with you? I think you should all do it. Okay. So I'm going to say hours equals, and I'll say I hours. Okay. Input. Okay. Let me put colon. Okay. And then I say I rate equals input. Okay. And this is good. So what we do is we first of all convert the hours into integer, right? And we also convert rate into integer. And then we multiply like this. But since if hours are greater than 40, okay, and we say total equals 0, okay, and we say total plus total equals total plus, okay, or we can say if extra hours equals 0, and we just compute the extra hours using this. Okay, so we say extra equals the hours minus 40, and so pay equals the, okay, so and here what we do is hours equals 40. Okay, so whatever extra is there, I'm just trying to do it in a very simple way. This is correct. So whatever the extra hours are there, we are multiplying that with 1.5. Okay, and the base ones are basically on the same rate. So we are saying 45 and we are saying 10. What does it say? It says extra is not defined. Why? Because we have used extra in a wrong way. So we are saying 40 and 10. Oh, we did not print it. Okay, so 45 and 10. This makes sense to you? All right, are you doing it? Great, great. So many people have done it. So, okay, so Gopi is saying that the line 3 has syntax error. So let me see Gopi's code. Okay, so it says this. Okay, if this is here. You have to put colon here, right? Copy colon here. And similarly, you have to put colon here, right? Otherwise, your logic seems to be correct. Okay. Also, you can just remove this one print statement and use this one. Okay, so 45 and 10. Good. So your logic is right. All right, good job, Gopi. So you can put colon here and correct it. Anybody else? You can write your own logic. You can see that the logic between there's a difference between my logic and Gopi's logic. Gopi's logic is, I think I like his program more than mine. All right. So okay. So you can build a similar logic. Done, everybody? Do it right away. It'll be good. This is basically make you, think a bit. All right. Only 4 people have done in the class so far. Good, 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 good. All right. So should we move on? Or is somebody stuck? Do you need help? Great. Wonderful. Wonderful. Now, let's improve upon this code. Okay. Let's improve upon this code whereby it should be able to handle the non-numeric input gracefully. Okay. It should be able to handle non-numeric input. Okay. Now let's modify this piece of code so that it should be able to handle the errors. Okay. What if the user, what if here the user has entered something really, really wrong, something wrong. So here what we could do is we could say try, okay, and we could say accept, and in this we could say I'm just trying to make it look okay. Okay, so here we're saying print enter valid. Okay, so when I run it and I say something like this, let's say please enter valid value. Okay, if I enter something like this, let's say please enter valid value. Okay, are you able to fix it? Noor, is this working or you want me to take a look at it? Okay, let me take a look at it. Okay, this is the code from Node. And let me see. Let me just print the wage at the end of it. Good. Okay. So sometimes the variable becomes red. It means that those variables are inbuilt functions or special values. Okay. Okay. So great. Now, are you able to handle the errors when it enters something really wrong? Okay. Fine. Able to write try except? Yes. If not, then please do so. Okay. Any questions so far? Should we move ahead? All right. Great. Great. So you have to rewrite your pay program using try and except so that your program handles non-numeric input gracefully. Okay. A question from Vinudeep is how to pass control back to try after except. That's what we are going to learn as part of loops. Okay. Okay, there's an error which Raghu is facing. The error is unsupported operand types for plus, none type, and float. Okay, let me take a look at Raghu's problem. So let's take a look. I think you all can put in your inputs as well. So here we're defining hours as something like this, right? Then we're defining rate if this. Okay, so this is what we have. All right. So let me see. Okay. And if I print, okay, it did not happen. What is wrong with this? This is right, correct? Why? Oh, it's taking time to execute. Is there something missing here? A kernel is stuck. Let me try again. Enter the hours. So I entered 45. Wait, entered 10. So at this point, what has happened is if hours are greater than 40, then okay, this is good. Then you're multiplying it. This is good. And here. So what you have here is we are basically adding two things, correct? And here, this bracket is closed here. Okay, this bracket is closed here. So that's the reason, just a second. This is good. Okay, so we subtracted this. We forgot the bracket of print actually. That's all. Okay. Right. We basically forgot the bracket of print. Okay. Thank you, Dhyan. Okay, what's the difference between skip and break in Python? We are going to talk about it soon. All right. That's the next thing. Wonderful, wonderful. So I'm very happy that most of you are able to code for the first time and write your conditions. Great, great, great. Those who are already aware of programming, my request would be that they should help others in the session and the way others are already helping, right? And right, that's the way we can go forward. All right, wonderful, wonderful to have great audience. Let's move ahead. Let's move ahead. So great, great. All right. So this was the first interaction. So the moment you are able to do if else, that is the first interaction up to programming. And you will, as we go forward, you will see more constructs which are very interesting and gives you far more control over the logic building. All right. So what we covered so far is we talked about comparison operators, we covered about nested decisions, we covered about logical operators. Talked here. Let me see. Did I miss it? Okay. So we can write if conditions in between. Okay. So we could write. Let me just give you a brief here. So it's very simple. So let me just go full screen and go back here. All right. So we could actually write things like things and or and more. Okay. So all right. So we could write things like, let's say x is 10. We could write if x is greater than 10 and x is lesser than 100. This is the way we could build logic. Okay. So let me say this is 20. So we could say print tens. Okay, so you can see that it has worked. And if we could also say if x equals 0 or x is less than 1, okay, less than 0, we could say print too low. Okay, so if you say put -1, it'll say too low, or if it says 0, it'll say too low. See? So basically, you could put and or and combine the conditions together. Okay? We can combine the conditions together by putting and or. And we can keep on adding more and more such conditions. Okay? And of course, we can put brackets around things. We want to say this or x is something, right? Then all right, so we could say y greater than 10. Okay, so this way we can build all kinds of conditions. Okay, so there is no, I mean there's no need of the spaces as such, but it's better practice to write spaces. Okay. It's better practice to keep spaces between the operators like the way we have done here. Okay. All right. So basically, this is the way you can start with with forming really complex conditions. Okay, so those who are mathematically inclined, here is a quick question for you, and this is an important question. So let's say we have a rectangle in which left corner is defined by 4 numbers: left, x, sorry, we call it, okay. How do we define rectangle? Rectangle is defined by left top and right bottom. Okay. Okay. Left top underscore x and left top underscore y. These are the 4 numbers. And right top underscore x and right, okay, y. So these are the 4 numbers that we are given. Okay, we are given, let's say, all right, let me just copy paste it. Let's say okay, so here is a rectangle. Here's a rectangle. These coordinates are representing our rectangle. Left corner is at 0, 0. Right corner is at 10, 20. Okay, right bottom. Correct. That's how we generally define a rectangle, right? By, so when we, let's say this is a rectangle, so this is a left coordinate and this is the right coordinate. Correct. So we have to say find out if x equals 30, y equals, if x is say 5 and y is 5, is x and y is this point inside rectangle. Okay, you have to find that out. So you'll be given these 4 numbers along with these 2 numbers. You have to find out if this number, this point is inside the rectangle. Okay, so take it as an exercise that given a rectangle, if we have to find out if a point is in the rectangle, you have to print yes, else you have to print no. So the point x and y, x should be lesser than, x should be between the left corner's x and right bottom's x. Similarly, y should be between this. Only then it'll be inside the rectangle. Correct? So the condition will go like this. You can build. You want to keep it as a homework for yourself. Is the question clear to everyone? Please interact. Is the question clear to everyone? If not, please clarify. So this is kind of an assignment that you have to do by yourself. Okay. Please note that a number could be negative number, and an integer could be a negative also. Similarly, float could be negative also. Great. You can do it at your own time. So this is homework for yourself. All right. Now moving ahead. So these are the things that we understood, and there is also a not operator. Not operator means it inverts the condition completely. So we could say here, if not of ours, then do this. Otherwise, do this. Okay. All right. So the answer would remain the same. So not means the opposite of this. Not of hours greater than 40 means if the hours are lesser than or equal to 40, right? So we could use the not operator as in when we need. All right. We also learned one-way decision, if-else conditions, else-if also we learned, and we also learned try except, and we did some of the questions. Okay. All right. So this was a quick overview of if-else conditions and try except. Okay. Good to move on. Let me minimize that. Okay. Great. Now, very important part of the Python or any language. Okay, very important part. It is called functions. Great. Is everybody back? So those who are doing the homework, they can drop it for now. You can do it. You can do it and submit tomorrow. You can just it'll reflect. This question will reflect in Cloudx Lab. You can do it there. All right. So here we go. Here we go. So all right. So when we are doing something, when we want to do something again and again, then it's better to combine multiple steps and keep it in a function. Okay, that's called a function in Python. So if you expect certain things to be done again and again, those can be combined together. Those steps could be combined together and kept as functions. For example, we wanted to say hello fun multiple times. So instead of we typing it again and again, what we did was we combined these two into a function. So we said def thing colon, then space, and then first statement, second statement. Okay, so now what we have here is we have defined a function called thing. So whenever we are going to call thing, it's going to execute everything in it. Okay, it's going to execute everything in it. This is called a function. Okay, so when we say thing, when we call thing, it's going to print hello fun, hello fun. Let me show you how does it work. All right, so I'm going to just type it. It's not going to take too much time. So we are saying that thing, and we're going to print hello, and we're going to print fun, right? So we just defined a function and we could call it. Okay, and we can call it as many times as we want. Okay, so we don't have to type print fun again and again. Okay, this is called a function. Function is nothing but a program which is given a name, and you can call it from the same program. So that's a function. So these are multiple instructions. So function can have everything a normal program could have. It could have if-else conditions, it could have try except, it could have expressions, it could have every kind of thing. So if we have to create a function called addition, we could simply say def add, and we say x comma y. Now these are called argument to the function. These are input parameters to the function. Okay, these are input parameters to the function, and The function could also just add these numbers. I'll talk about this in a while. So we could call this function just like we called print. Print was the first function that we used, and here we are just defining our function called add, which adds two numbers, and we are passing these. So here it's just adding two numbers. Okay, it's just adding two numbers, and if we call it with string, right? If we call it with a string, so we could say 1 and 2. Now it's 12. Do you find the difference? So it's basically adding two strings in the second one. So a function could have arguments. Arguments are something that we pass when you call. Yes, we can use try except inside the function, as well as while calling a function, we can put try except around it. Okay, so let's say here we are expecting certain error. So what we could do is we could do try except here and try except here and say int. Oops. Okay, so we could happily. Okay, so if I let's say pass 1 and 2, now it will say oops, because it cannot add 1 and 2. Good question. Good question, Edwin. All right. So a function could be very simple as this, where it's not taking any argument and just doing some operations. A function could also take arguments. Within the bracket, we have said that x and y is what I'm going to give you, and it's doing certain things inside it. All right. So this is basically reusing existing steps again and again. So bunching multiple instructions together, or combining multiple instructions together, is called functions. So there are two kinds of functions in Python. One is called built-in functions, like the print or the input that we have used. Similarly, we used type function that gave us the type of anything. Then we also used float to convert a string into float, and int to convert a string into int, and functions that we define ourselves and then use. These are the functions that basically these are user-defined functions. We just define a function called thing and add. So we treat the built-in function name as new reserved keywords. Okay, so built-in functions, though you can override them, you can define a new function with the same name, but we want to avoid them. Okay, so basically, by using functions, it gives us the ability to define our own libraries, our own modules, and that is something really important. All right. So the function further can take arguments. It's a reusable piece of code that takes argument as input and does some computation, and then returns a result or results. Okay. So we define a function using def keyword. We call the function by using the function name and parentheses followed by the arguments. Okay, so if let's say we are trying to we have a function called max. This max function is taking an argument called hello world, and then it's returning the maximum value out of whatever argument is passed. So now the function can return a value the way input function returned us the value inputted by the user. So similar way, this function, max function, is returning us a value. When you're calling this function, it's returning a value and assigning the result to base. So max does something, it takes this as an input and gives you this value as the output. Okay? All right. Very good question. A function can call other functions. Okay, and as a matter of fact, a function can also call itself. That's called recursion. We're going to talk about this. Okay, so here the max function is basically returning a value. A function is some stored code that we use. A function takes some input and produces an output. Okay, so to make our life easier, we basically, if there is a certain piece of code that we are going to use again and again, instead of typing again, we basically write that in a function. A function can give output and function can take of arguments. Okay. A question from Noor is how can we clear Jupyter sessions so that it forgets the variable names that we have previously defined? So to clear the variable names, you need to restart the kernel. And to clear the entire thing, you will have to use clear toolbar icon. Okay. So you could say here. Okay. So you could basically say kernel restart. All right. Because the variables are maintained by the Python interactive shell, which is launched by this Jupyter, and that's called kernel. So kernel can be restarted, and then it'll forget it. Okay, all right. So we used functions while doing type conversions. For example, float converted this into a number, and similarly, the type printed the type command printed the data type of a value. Float function converted the argument. The float function converted the argument into a float. So float is taking this as input and giving this as the output. Okay, so keep this in mind. Type is taking this as input and giving you the string, this value as output. Okay, or printing on the screen and so on. Also, printing on the screen is not same as returning a value. All right. Similarly, string conversions, you can basically use there are many. You can use int float to convert between strings and integers, and you will also get, so let's say you want to convert a number into a string. So what you do is string1 plus string2. So it will convert 1 and 2 to strings and concatenate them. Okay, so that way, these are the functions that we have used so far. Now, to build our own functions, we use the def keyword followed by optional parameters in parentheses. We indent the body of the function. This defines the function and does not exclude. Okay. All right. So once we have defined a function, we can call or invoke it as many as times as we like. This is the store and reuse pattern. Okay. So here, this is where we are calling this function again and again. See that? All right. Great. All right. So the function takes argument, and these are the input to the function, and these are basically parameters. Okay. So I'll show you. Let's define a function called greet. Okay. This is our function called greet. I'm going to edit it a bit using the text editor. And all right, I think this will be okay. All right. So this is my function called greet. Let me copy it to. Okay, let me copy it here. So here, the function greet is taking an argument as length. It is comparing length with this and printing similarly this. Okay, so greet, when you call it with a string, greet, let's say English, right? So, and if you say yes, it's printing hula. Otherwise, if you say friends, printing, right? So basically, this is a greet function which takes an argument length. It compares, if it's yes, then print this, and so on. So it's not giving us any return value. It's returning empty. So return values are something very interesting. Return values, so you can define greet function, and you have a return value here. So, okay. So here it's returning hello, and you can use that value somewhere. Okay. So let me show you, let me just change it a bit. This time we are returning hola. Okay, and all right. Great. So let me just call it here. So I can assign the return value to something and then use it however I want. Okay, however I want. Here. So if we did not return, we cannot assign like this. If we said print here and did not return any value, the value of x is going to be none. Say, for example, if I say x equals, let's say here, it was the earlier version. It was, let's say, earlier version like this. And here I called x equals greet, greet, and here, right? So the value of x is going to be, nothing. You see, the type of x is none type. You see that? So if I do not return value, the function will not return anything here. Okay. Okay. Vinta, we'll talk about dictionary and get as we move forward. Okay. Don't worry about it. All right. Thank you, Shahrukh. Great. And all right. So what you see is that if a function is not returning anything, it's basically returning none. All right. And here, the function is basically returning something, and therefore the value of x is that value returned by the function. You see the difference between the two? This one returns something while the second one does not return. Okay. This one returns something, this one does not return anything. All right. So basically these are return values. All right. This diagram will make it very clear. And basically, it's very simple thing. It's not too hard. So here, the function that we discussed earlier, the add2, we are giving two variables as argument, and we are adding them and printing those values. A question from Christy is it possible to have int and float? I think it's Edwin. So question from Edwin is it possible to have int and float as parameters to the function? Of course. So you can have, basically the function definition is what governs the thing. Like, all right. So it's up to the caller to give the data type of the function. The function does not declare any kind of data type. All right, let me go back here. Say, for example, here we have defined x and y, right? Now, the caller will pass a value, and that value carries the data type. See? So here, it's able to add float, it's able to add strings, and it's also able to add integers. Okay. You can see that it's able to add the integer with the string. Okay. Similarly, this. Okay. So Python is not a strongly typed language, and the value of return type is determined by actual value. The way the data type of arguments is determined by actual value. Similarly, The value of return type is determined by the value you're passing. So Python does not declare data type. It does not say that greet function is going to only return this or that. It does not say that greet function is only going to take this argument or that kind of argument. It just lets you call it with any kind of value. Okay. Now you can see that we have defined this addition function, right? And we did not define it for integer or float. Imagine that add would, ask you for define the data type also. Now, instead of defining a single function, you would be defining like 10 functions, one for double and double, one for float and float as in decimal number, float and float, integer, string and string, integer and double, string and double, and so on. So it will take it forever. It will take us forever to write such kind of function. And that was one of the reasons why most of the Java code or why most of the C++ code was too lengthy. Okay. Good. Do I make sense to you? And all right. So basically, Python does not impose, or the definition of a function does not include the data type of arguments or the return type. Okay. So function definition is what are the arguments it's taking and what the value it returns. That's all. All right. So basically, it makes it very much possible to kind of build very generic systems. If it is mandatory for you to ensure that the data type of a particular argument should be this, then you can put an if condition at the top of your function. If you define a new function with the same name, it will override the older function's definition. Okay? It will override the old function's definition. Okay? Just like we could assign values to functions, values to variables again and again, in the same way, we could define the function again and again. All right? Okay, so the functions that do not define and do not return anything are called non-fruitful function and do not return anything. Okay, and a very important part is organize your code into paragraphs, capture a complete thought and name it, and then you call it a function. Do not repeat yourself, make it work once and then reuse it. Okay, these are the reasons why people define functions. If something gets too long or too complex, break it up into logical chunks and put those chunks in the functions. Okay, so when you are writing a piece of logic and it's becoming really complex, you will have to kind of think about the logical constructs that are building up the entire logic, and each logical construct you give it a name. And that way, your code will remain very much readable as well as maintainable. Also, when your code looks really easy and simple, it becomes easier to innovate on top of it. Also, you could make a library of function and keep it in a separate file and then use it. I'll show you how to use your functions from another file. Okay. We'll also talk about creating local files and other things. Okay. Okay. Without which get are we talking about? A question is to all of you. We write your pay computation with time and a half for overtime and create a function called compute pay, which takes two arguments, hours and rate, and print the value. Print the value. get or input. Okay, so you can take it as a homework. All right. So you have to create a function that does the compute thing. Okay. So something that does the compute thing. Okay. So you have to define a function called compute pay. And all right. So today we learned a new thing called functions. And from tomorrow, we are going to, tomorrow I'm not going to repeat what we did today. Tomorrow we are going to continue with the advanced constructs. Okay. Do not miss the class tomorrow. It's going to be very important. Tomorrow at the same time. All right. I look forward to see you tomorrow and finish these exercises. These exercises will reflect in the my courses also. And Noor, your session, I will take a look why you are not able to log in. All right. Great. Great to have all of you in the session. It was wonderful to have so many questions. And I request all of you to work with me during the session. That's the only way to learn. That's the only way to learn. And okay, great, great. I'm really happy that you are able to code and get your baby steps. And as we are going forward, you all have to basically do the exercises together. Otherwise, you always feel left behind. Okay. So there are a couple of exercises that we have given today. Finish those and put them in my courses. These problems will reflect in your courses maybe on Monday. All right. So wonderful to have all of you in the session. I look forward to have more participation with you. And bye bye. Have a good day.